Problem 100, Quantum Mechanics. The question is, two vectors, column matrix A0 and column matrix BC are orthonormal if we have the orthonormality condition is integral psi m star psi n dx is equal to delta mn. The value of the integral is 1 if m is equal to n and 0 if m not equal to n. If psi 1 and psi 2 are orthonormal, then we can say that the inner product of psi 1 with itself is 1, the inner product of psi 2 with itself is 1, and the inner product of psi 1 with psi 2 is 0. Let ket psi 1 equal to column matrix A0 and ket psi 2 is equal to column matrix BC. Then we can say that bra psi 1 is equal to row matrix A0 and bra psi 2 is equal to row matrix BC. Now let us use the first condition, that is the inner product of psi 1 with itself is equal to 1. This implies that row matrix A0 into column matrix A0 that is equal to 1. This implies A square is equal to 1 or A is equal to plus or minus 1. Now let us use the second condition. The inner product of psi 2 with itself is 1. This implies that row matrix BC into column matrix BC is equal to 1. And this gives B square plus C square is equal to 1. Finally, let us use the third condition. The inner product of psi 1 with psi 2 is equal to 0. The inner product of psi 1 with psi 2 is equal to 0. This implies that row matrix A0 into the column matrix BC is equal to 0. This gives AB is equal to 0. This gives AB is equal to 0. Already we have A is equal to plus or minus 1. Therefore, we can say that B is equal to 0. We have B square plus C square is equal to 1 and we have proved that B is equal to 0. Since C square is equal to 1 minus B square and B is equal to 0, we have C square is equal to 1, thus C is equal to plus or minus 1. Now we have A is equal to plus or minus 1, B is equal to 0 and C is equal to plus or minus 1. Option C is correct.